Our physics laboratory proposal is all about projectile motion, in which we use the game Dodgeball as an example. Projectile motion occurs when objects are fired at some initial velocity or dropped and move under the influence of gravity. There are three cases of projectile motion. What we did is the third case. Now, we need to solve for the time on how much the ball spent in the air and what is the velocity of the ball just before it lands on the hands of the other thrower. For this example, assume that Vince has the ball and is located 1.67 meters from the ground at an angle of 40 degrees with the horizontal and is 5.25 meters away from Vic. At what initial speed must Vince throw the ball in order for Vic to catch it? Vic is at height of 1.75 meters. Solution. For letter A, how much time does the ball spend in the air? And for letter B, what is the initial speed of the ball? The required is initial velocity. For letter B, at the horizontal, for us to solve for the initial velocity, we first use the manipulated kinematic equation, and that is delta x is equal to initial velocity times the time, and it is manipulated to delta x is equal to initial velocity times cosine theta times the time. We then substitute the distance and the theta, and it turns out 5.25 is equal to initial velocity times cosine 40 times the time. To get what is required, the equation is manipulated for us to find the initial velocity. Initial velocity is equal to 5.25 divided by cosine 40 times time. Now, we don't know what is the time, so we go to the vertical component. We then use the second kinematic equation. Delta y is equal to initial velocity of y times the time plus 1/2 of gravity times time squared. Then it is manipulated and resulted to delta y is equal to initial velocity of x times sine theta times the time minus 4.9 times time squared. In the free body diagram, there are height 1 and height 2. We must subtract it to get what is needed for delta y, and the result is 0.08. We then substitute it to the delta y, then it turns out to 0.08 is equal to initial velocity of x times sine 40 times time minus 4.9 times time squared. Next, we substituted this initial velocity. We got 0.08 is equal to 10 divided by cosine 40 times time times sine 40 times time minus 4.9 times time squared. As you can see, the time cancels out, and as you observe, there is a trigonometric identity, the sine over cosine. After this, we then use the tangent because it is the identity of sine over cosine. The results were 0.08 is equal to 5.25 times tangent 40 minus 4.9 times time squared. In order for us to get the time, we then manipulated it, and turns out time is equal to square root of 5.25 times tangent 40 minus 0.08 divided by 4.9, and the time is equal to 0.94 seconds. Now that we have solved for the time, we then get its value and substitute it here. Then we solve it, and we have the initial speed of the ball.